Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
For part A, let's first start by balancing the two redox equations. Equation 1 is HNO2 plus I minus to NO and I3 minus. We'll break this apart into two half reactions. We get HNO2 to NO, balance the oxygen, let's balance the hydrogen and we'll balance the balance the charge by adding one electron here. And second half reaction, I minus to I3 minus, 3 there to balance the iodine, and 2 electrons to balance the charge. We're going to double the first half reaction to be able to cancel out the electrons. And balanced, we get 2HNO2, add 3I minus to 2NO, I3 minus, add 2H2O. So here's our first half reaction, or sorry, our first redox reaction that is balanced. And let's balance the second equation. Second one will be I3 minus, add S2O3 2 minus to I minus, and S4O6 2 minus. Break this apart into two half reactions. Put a 3 here to balance the iodine, and 2 electrons to balance the charge. S2O3 2 minus to S4O6 2 minus. We'll put a 2 here to balance the sulfur. And oxygens are already balanced. 2 here to balance the charge. 2 electrons will cancel. 2 S2O3 2 minus. Add I3 minus to 3I minus and S4O6 2 minus. There's our second equation balanced. And now for part B, we're going to use these two balanced equations, and we're going to find the mass percent of the NO2 minus ion in the sample. Okay, so we're going to find that we have point, so from the titration, sorry, 18.77 milliliters of Na2S2O3. So let's convert to liters. 0.01877 liters Na2S2O3 and times the molarity, 0.1500 moles of Na2S2O3 per liter of Na2S2O3, and 1 mole of Na2S2O3 is equivalent to 1 mole of S2O3 2 minus, and this works out to 0.00282 moles of S2O3 2 minus. So starting from 0.00282 moles of S2O3 2 minus, we have 2 moles of S2O3 2 minus to 1 mole of I3 minus. We get that from our balanced equation. And we also have 1 mole of I3 minus to 2 moles of NO2 minus times 1 mole of NO2 minus has a mass of 46.0 grams, and this would be equal to 0.130 grams of NO2 minus. And this will be the mass percent of NO2 minus would be equal to 0.130 grams over the 2.935 grams in the sample times 100%, and this would work out to a mass percent of 4.4% for the nitrite anion.